Hello my scholars, you are welcome to my school YouTube channel and my name is Bank. In today's video, we shall be tackling JAMB CBT physics past question for the year 2005. So relax, do not go anywhere, I will be right back. You are welcome back to my school YouTube channel. In today's video, we shall be answering question 26 to 50. So let's begin with question 26. Satellite communication network makes use of A. Visible light, B. Sound wave, C. Radio wave, D. Infrared wave. So the answer to this question is option C, radio wave. Okay, so radio waves are used in satellite communication to send signals between satellites and ground station. Okay, due to the ability of radio waves to travel long distances and penetrate the atmosphere effectively. Okay, so that make option C the correct answer to this question. Question 27. An electric device is rated 2000 watts. 250 volts. The correct fuse rating of the device is, so let's move over to the board to provide answer to this question. Now remember that electrical power is given as P is equals to IV. Okay, so here we're actually looking for current, so we just make current the subject of formula since we are giving voltage and we're also giving power. Okay, so the value of power that is given to us is 2000 watts. So here we have 2000 watts, that will be equals to current, okay, times the given voltage, which is 250. So since we are looking for current, we simply divide both sides by 250. So the current will now be equals to 2000 divided by 250. So 0 will cancel out 0, 5 here will be 5. 5 here will be 40, then 5 here is 1, 5 here will be 8, okay? So the value of the current I is equals to 8 amperes, okay? So let's return back to the screen to pick the correct option for this question, and that is option B, 8 amperes. Question 28. The north pole of a magnet can never be separated from the south pole because of the property knowledge as A. Magnetic octopole, B. Magnetic monopole, C. Magnetic dipole, and D. Magnetic quadrupole. Okay, so the answer to this question is magnetic dipole. Okay, so by magnetic dipole, we are actually saying that a piece of magnet consists of both the north pole and the south pole, and these two poles exist together. Okay, it's literally impossible, okay, to separate these two poles. Every piece of magnet has both the north pole and the south pole, hence it is referred to as magnetic dipole. Because these two poles exist together, they can never be separated from one another. So that makes option C the correct answer to this question. Question 29. A car battery rated 45 ampere hour is charged with a charger whose rating is 2.5 amperes. How long will it take to charge the battery full? So let's move over to the board to provide answer to this question. Okay, so battery capacity, let us call it BC. So battery capacity is given as time, okay, times charger current. Okay, charger current. So in this case, the charger current is given to us to be equals to 2.5 volts. Okay, that is what is referred to as the charger whose rating is 2.5 ampere. Okay, so here we are actually looking for time, that is how long it will take to charge the battery to full capacity, since we have been given the battery capacity to be equals to 45 ampere hour. So here we put 45, and this will be equals to time, which is what we are looking for, times the charger current, which is 2.5 ampere. Okay, so in order for us to get the value of T, we simply divide both sides by 2.5. Okay, so that our T will now be equals to 45 divided by 2.5. Okay, so we can increase this. We can remove this decimal point by multiplying it, by multiplying 2.5 by 10. Okay, and we also do the same thing to the numerator, which is 245. Okay, so that the fraction will be equivalent, will be equal. So here we have 450. That is, if we multiply 45 by 10, Then if we multiply 2.5 by 10, we'll be having 25. So we can now reduce, okay? So 5 here is going to give us 5, and 5 here is going to give us 90, okay? Then 5 here is going to give us 1. 5 into 9 is going to give us 1, okay? Remainder 4. So 5 into 40 is going to give us 8, okay? So it's going to take 18 hours for the battery to be charged to full capacity. So let's return back to the screen to pick the correct answer to this question, and that is option B, 18 hours. Question 30. The electric field intensity in a place where a charge of 10 raised to the power minus 10 coulombs experiences a force of 0.4 Newton is. So let's move over to the board to provide answer to this question. But you must remember that electric field intensity is the force acting per unit positive charge, okay? So that E, which stands for electric field intensity, is equals to force all over the positive charge, okay? So in this question, we're actually calculating for the electric field intensity. So force is given to us, and the charge, the value of the charge is given to us to be 10 raised to the power minus 10. Okay, so we're just fixing our value. So if we put this here, we'll be having 0.4 all over. So we multiply this by 1, it still remains the same. So you'll be having 1 times 10 raised to the power minus 10. So we can write this in standard form. So that we'll be having 4 times 10 raised to the power minus 1. Okay, since we're moving our decimal point from our left to our right, so the power of 10 here will be negative. Then divided by 1 times 10 raised to the power minus 10, okay? So we just divide 4 divided by 1, still remains 4, then times. So here we apply the law of indices. So we take one of the 10, since we are dividing, we are going to be subtracting the powers. So you'll be having minus 1, then minus 10. So minus definitely is going to change to plus. So you'll be having minus 1 plus 10. Okay, so that at the end of the day, we now have 4 times 10 raised to the power 9 Newton per coulomb. Okay, so this is the value of the electric field intensity. So let's return back to the screen to pick the correct answer to this question, and that is option D, 4.0 times 10 raised to the power 9 Newton per coulomb. Question 31. 2 charged particles are projected into a region where there is a magnetic field perpendicular to their velocities. If the charges are deflected in opposite directions, which of the following statement is true of the charge? A, the charge must be of opposite sign. B, positive charges are more in number. C, the charges are electrically neutral. D, the charges are of the same sign. Okay, so the answer to this question is option A, the charge must be of opposite sign. Okay, and the reason for that is because the magnetic field acts, okay, on the charged particles in a direction that depends on the sign of the charges. Okay, this implies that opposite charges will be deflected in opposite direction, meaning that the positively charged particles will be deflected to the negative side of the magnetic field, while the positively charged particles will be deflected to the negative side of the magnetic field, while the negatively charged particle will be deflected to the positive side of the magnetic field. So that makes option A the correct answer to this question. Question 32. The resistance of a piece of wire of length 20 meters has cross-sectional area 8 times 10 raised to the power minus 6 meters square is. So we are given the resistivity of the wire to be equals to 4 times 10 raised to the power minus 7 ohms meters. So let's move over to the board to provide answer to this question. So basically, to solve this question is just for you to remember the factors that affect the electrical resistance of a wire. Okay, so the factors that affect the electrical resistance of wire basically that we need here are the length and the cross-sectional area. Okay, so the resistance arrow is actually directly proportional to the length, okay, and inversely proportional to the cross-sectional area. Okay, but in order for us to have an equal to here, we must introduce a constant which is known as the resistivity. Okay, so let's introduce the constant, which is resistivity. So from here, since we are calculating for resistance, we can just substitute the values that are given to us for length, cross-sectional area, and resistivity into this equation. So that we'll be having 20 times 4 times 10 raised to the power minus 7, okay, divided by 8 times 10 raised to the power minus 6. Okay, so let's multiply these two. So if we multiply 20 times 4, we'll be having 80 times 10 raised to the power minus 7 all over 8 times 10 raised to the power minus 6. Okay, so 8 here is 1, 8 here will be 10. Okay, so at the end of the day, we still have 10 times 10 raised to the power minus 7. So here we can apply the law of indices to tidy this part up. So here will be times, okay, here will be divided by. So in that case, there's no need for us to put that division. So we already know that since the base are the same, definitely we are going to subtract the powers. So since here we have 10, so since we already have our 10 here, so we just subtract the power. So we'll be having minus 7, then minus 6. Okay, so remember minus is going to change to plus, so that we'll be having 10 times 10 raised to the power minus 1, because minus 7 plus 6 is going to give us minus 1. So minus 1 is the same thing as, say, of course, minus 1 means there's an invisible point here, so you have to move it one place to your left. Okay, so if we move down the point here one place to our left, we'll be having 1.0 ohms. Okay, remember that the unit of resistance is in ohms. Okay, so that is the value of the resistance of the wire. So let's return back to the screen to pick the correct answer to this question, and that is option D, 1.0 ohms. Question 33. The figure above shows a plot of angles of deviation through a glass prism when light is incident at theta degrees on the prism. The incident angle that produces the minimum deviation is, okay, so this is the diagram that we are asked to use to get the incident angle that produces the minimum deviation. So we just go to the minimum deviation line, okay, which is the vertical axis, and we trace at a line that just touches, okay, the base of this curve. Okay, so if we trace like this, we are going to be having 18, and when it touches it at this point, we trace it down. So if we trace it down, we are going to be having 25 degrees. Okay, so what that shows is that the angle of incidence that produces the minimum deviation is equals to 25 degrees. So that makes option D the correct answer to this question. Question 34. The value of F in the figure above when in equilibrium is. So basically, to answer this question, we normally use the Lem's theorem. Okay, but for this, we are not going to be drawing the diagram. Okay, normally we are supposed to draw a rectangle to represent these forces, then we can now solve for the unknown force here. Okay, but we just go straight, it's still the same thing. So let's move over to the board to provide answer to this question. So this is the diagram that is given to us, and to answer this question, we have to use the Lem's theorem. Okay, L-A-M-I-X theorem. Okay, and the Lem's theorem is almost similar, or is similar to our sine wave mathematics. Okay, so it's just for us to deal with the sides that are facing the angles that are facing the force. So if you look at the 10 Newton force, is facing the angle of 150. And if you look at the unknown force, okay, this place is F, not 17. So if you look at the unknown force, it's facing angle 90 degree. And if you look at the 10 Newton force, it's facing the angle 150 degrees. So we have F is equals to sine 90 degrees should be equals to 10 all over sine 150 degrees. Okay, so like I said earlier on, the Lem's theorem is similar to the sine rule in mathematics. So remember that sine 90 is equals to 1. So you'll be having F all over 1 to be equals to 10 all over. Now remember that sine 150 is also equivalent to sine 30, okay, and sine 30 is equals to 0.5. So you'll be having 0.5. Okay, so since we are looking for F, we can, because F divided by 1 is still F. Okay, so we just divide. Okay, 10 divided by 0.5. And remember that 0.5 is the same as 1 over 2. Okay, so if we invert this, we'll be having F to be equals to 10, okay, times 2, and that will be equals to 20 Newton. Okay, so the unknown force is equals to 20 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option C, 20 Newton. Do you know you can take practice questions with our JAMB simulated CBT past questions? All you need to do is to click on the link in the description below, and that will take you to my school website. There you will have to download my school mobile app for your Android devices and my school software for your laptops and computers. Please go ahead and start practicing. Moving on to question 35. In the figure above, the coefficient of static friction is 0.5. If the tension in the string is T, the acceleration of the system in motion is. So let's move over to the board to provide answer to this question. So remember that force is equals to MA, okay, where M stands for mass and A stands for acceleration. So in this question, we are looking for acceleration, okay, but we are given this pulley system, okay, but here we are told that this surface is rough. Hence, we are given the coefficient of friction to be equals to 0.5. Okay, so the F here is actually equal to the tension, okay, here plus the tension here. Okay, so if you look at the diagram carefully, you discover that this mass here is actually pulling this one down. Okay, meaning that the value of the weight of what is here is greater than the value of what is here. Okay, but this force is equal to the tension here plus the tension here. Okay, but since this particular one here is pulling this other one down, it means that what we have here is greater than what we have here. So in this case, we'll be having T, so let's put 6, okay, will be minus T, let's put 3, and this will be equals to MA. But remember that the M here, okay, is equals to these two masses, which is the 3 kg and the 6 kg mass. Okay, so let's get the tension here. So remember, tension is the same thing as force. Okay, but remember, since the surface here is rough, that means coefficient of friction is going to come into play. Okay, so remember that coefficient of friction is equals to force all over normal reaction. Okay, and normal reaction is equals to mass times acceleration due to gravity. So since we are looking for this force, okay, we just cross multiply, so that F will now be equals to coefficient of friction then times the normal reaction, which is mg. So let's get the value of F, which is the tension, okay, on the string here. So F will now be equals to 0.5 times 3, which is the mass, then times acceleration due to gravity, which is usually taken as 10. Okay, so this will be equals to 1 over 2. Now remember that 0.5 is also equal to 1 over 2. So in place of 0.5, we can replace it with 1 over 2. The essence is just to make our division easier for us. Okay, times 3, then times 10. So 2 here is 1, 2 here will be 5. So that if we multiply 3 by 5, we'll be having 15 Newton. Okay, so the tension here is equals to 15 Newton. So let's calculate for the tension here. So to get the tension here is still the same thing. Remember, basically weight is also equal to force, because weight is the force that is acting on an object due to gravitational pull of the earth. Okay, so here is equals to mg2. So here we'll be having 60 times 10, and that will be equals to 6 times 10, that equals to 60 Newton. So the tension here is 60 Newton. So you can see from the calculation that the tension here is greater than the tension here, and that's why this mass here is pulling this one down. Okay, so here we're having 60 minus 15, and that will be equals to this mass. No, I said earlier on that this mass is equal to the mass of 3 kg plus the mass of 6 kg. So if we add that together, we'll be having 9. So here we'll be having 9A. Okay, so if we subtract 15 from 60, that will be equals to 45, and this will be equals to 9A. So since we are looking for A, which is acceleration, we divide both sides by the coefficient of A, which is 9. So that A is equals to 45 divided by 9. and that will be equals to 5 meters per second square, okay, since we are calculating for acceleration. So let's return back to the screen to pick the correct answer to this question, and that is option A, 5 meters per second square. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next videos. Question 36. If the system above is in equilibrium, the tension in the string Q is, okay, so this is the figure above and this is Q. So if you look at Q very well, you'll find out that a weight of 4 Newton is attached to it, and below it, a weight of 5 Newton is also attached to it, okay? So what that implies that this Q is actually carrying 2 weights, okay? So if we add these 2 weights together, that will be equals to 9 Newton, okay? So the tension in the string Q is equals to 9 Newton, and that makes option B the correct answer to this question. Question 37. In the figure above, the work done by the force of 100 Newton inclined at an angle of 60 degrees to the object dragged horizontally to a distance of 8 meters is, okay, so for questions such as this, when we are asked to calculate for work done, okay, provided angle is given to us and that angle is inclined, okay, to the horizontal. From the diagram, we can see that the angle is inclined to the horizontal. We simply use the formula W is equals to F cos theta times X, okay, where S here stands for distance and F here stands for the given force, okay. So let's just substitute the values that are given to us. So here we'll be having 100, and remember that cos 60 is equal to 0.5, okay, so you'll be having 0.5, and remember 0.5 is also equals to 1 over 2, so I prefer to use that. So you'll be having 1 over 2 then times the 8, so 2 here is going to give us 1 and 2 here is going to give us 4, so that we are now left with 100 times 4, okay. So 100 times 4 will be equals to 400 joule, okay, since we are dealing with work done. So the work done by the force of 100 Newton inclined at an angle of 60 degrees, okay, to the object dragged horizontally to a distance of 8 meters is equal to 400 joules, and that makes option D the correct answer to this question. Question 38. In the circuit diagram of a transistor above, the terminals P, Q, and R represent, okay, so let's look at them one after the other. So this is the terminal P. Okay, so the terminal P actually represents the emitter. Okay, so let's just write it down so that we will not forget. So P is the emitter. Okay, so let's represent the emitter with E. Now, how do I identify the emitter? For the emitter, you will always see an arrow, whether the arrow is moving towards the base or is moving from the base. Okay, sometimes the arrow can as well face, okay, downward. Okay, then let's identify Q. Now, Q is the base. Okay, Q is the base. So this Q represents the base. So since we already know the emitter, we already know the base, then arrow here just represents the collector. Okay, so arrow is the collector. Okay, P is the emitter, Q is the base, and arrow is the collector. So let's check the options and see the one that agrees with what we have done. I think that should be option A. Okay, P is the emitter, Q is the base, and arrow is the collector. Okay, so option A is the correct answer to this question. Question 39. In the reaction above, S is, so this is the reaction above uranium, then plus electron, then barium, then krypton, then plus 2x. Okay, so they want us to identify S above. So to do that is just for us, first of all, to calculate the mass number of the reactant. So this is the reactant part, while this other part is the product part. So if we calculate the mass number of the reactant, okay, that would be equals to 236, which is 235 plus 1. So that will give us 236. Then we also calculate the mass number. So that will be 92 plus 0. Okay, so we also move to the reactant side. So let's just write it out. So we have 236 and 92. Okay, for the reactant side. So let's go to the product side. So for the product side, we also do the same thing. So we add these two mass numbers together, okay? So if we add these two mass numbers together, that is 144 plus 90, then we'll be having 234. Okay, that will give us 234. Then we also go for the atomic number. So we add these two values together, which is 56 and 36 together. So if we add 56 and 36 together, we'll be having 92. Okay, so we'll be having 92. So if you check the atomic number at the reactant side and the product side, they are the same. So there's no change. Okay, but then if we move to the mass number side, okay, if we check very well, you find out that there's difference of 2. Okay, there's difference of 2. So that means this S here actually is carrying, still have some mass number at the top. Okay, so now since here we have 2s, what it simply means that this S is actually a neutron. So here will be 1. Okay, let's put it plus, so we have 2x. So here will be 1. Okay, here will be 1 and here will be 0. So that if we add this to 92 plus 0, we still leave us with 92. Okay, because for this equation to be balanced, okay, the atomic number on both sides must be equal. The mass number on both sides must also be equal. Okay, so if you check the atomic numbers now, they are equal. But if you check the mass numbers, okay, they are not equal. So that means there's a number that is missing here. So the number that is missing here is actually 1, okay? And since we have 2 s's here, that means if we multiply the mass number by 2, if we multiply the mass number by 2, so we'll be having 2. So if we add 2 to what we already have here, we'll be having 236, okay, making the mass number to be balanced, right? So this S actually represents a neutron. Okay, so this S here is a neutron, and that makes option D the correct answer to this question. So this is just how you deal with questions such as this. Okay, so the correct answer to this question is D, neutron, meaning that S here is neutron. Question 40. Two liquids L1 and L2 are contained in a U-tube. The height and the density of L1 are 8 centimeters and 10 raised to the power 3 kilogram per meters cube, respectively. If the density of L2 is 800 kilogram per meters cube, its height measured from the same level is, so let's move over to the board to provide answer to this question. So from Hell's experiment, okay, we know that density is inversely proportional to height, okay? So that if we introduce a constant, we'll be having density, okay, times height to be equals to K, okay? Since this is a constant, okay, since density times height is a constant, then for this question, we'll be having the density of liquid 1 and the height of liquid 1 being equal to the density of liquid 2 and the height of liquid 2, okay? But we can as well use the ideas that for two liquids in a U-tube to be in equilibrium, their pressures, okay, the pressure on both arms must also be equal. So if we also use that, it will still work, okay? But if you look at what is given to us, the height is given to us in centimeter and the density is given to us in meter cube, okay, that is kilogram per meter cube. So we have to either convert the centimeter to meter to match up with this, okay, to match up with the density, the unit of the density, or we convert the density to grams per centimeter cube to match up with the height, okay? So let's convert the densities, okay, to gram per centimeter cube to match up with the height in centimeters. So if we do that, of course, in order to do that, it's just for us to divide this by 1,000. Now, 10 raised to the power 3 is actually equals to 1,000. So 1,000 divided by 1,000, that will be 1 grams per centimeter cube. Okay, we also do this to the second liquid, the density of the second liquid, and this will be equals to 0.8 gram per centimeter cube. So we just introduce those values into these formulas. So for P1, the density of P1 is 1, okay, since we've changed it to gram per centimeter cube, then times the height is 8, this will be equals to the density of P of L2. So the density of L2 is 0.8, then times H2, which is what we're actually looking for. So since we are looking for H2, we just divide both sides by the coefficient of H2, which is 0.8, so that H2 will now be equals to, of course, 1 times 8 is 8, so you'll be having 8 then divided by 0.8. okay, so if we want to clear this decimal point, we multiply both the numerator and the denominator by 10, okay, because this is to 1 decimal place, so in that case we multiply it by 10, so we'll be having 8 here, and here we'll be having 8. So with this we can easily divide. So 8 here is 1, and 8 into 80 is equals to 10, and that will be 10 centimeters. So the height of H2 is equals to 10 centimeters. So let's return back to the screen to pick the correct answer to this question, and that is option B, 10 centimeters. Question 41. 10 raised to power 6 joules of heat is required to boil off completely 2 kg of a certain liquid. Neglecting heat loss to the surroundings, the latent heat of vaporization of the liquid is, so let's move over to the board to provide answer to this question. So the relationship between quantity of heat and latent heat of vaporization is given as H is equals to ml, or you can use Q, whichever one is still correct. So the quantity of heat is given to us to be equals to 10 raised to power 6, which is the same thing as 1 times 10 raised to power 6, okay? Then this will be equals to the mass of the certain liquid. The M here stands for mass of the certain liquid. So in this case, is 2, then times L, which is the latent heat of vaporization that we are looking for. So since we are looking for L, we simply make it the subject of formula by dividing both sides by 2. So that L is now equals to 1 times 10 raised to power 6, then divided by 2. Now remember that 1 times any value still remains that value. So 1 times 10 raised to power 6 still remains 10 raised to power 6, okay? So 2 here will be 1, then 2 here will be 0.5. So we are now having 0.5 times 10 raised to power 6, okay? But this is not in standard form. So let's put this in standard form. So to put this in standard form, that means we are going to move this decimal point one place to our right. So once we move it from left to our right, we are going to be subtracting 1 from here, depending on the number of times we actually move the decimal point. So in this case, we only move it once, okay? That means this 6, we are going to subtract 1 from it. So if we subtract 1 from 6, we'll be having 5, okay? So that our final answer becomes 5 times 10 raised to power 5, okay? And that will be 5 times 10 raised to power 5 joules per kilogram. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option D, 5.0 times 10 raised to power 5 joules per kilogram. Question 42. The figure above shows 3 capacitors, 2 microfarad, 3 microfarad, and 6 microfarad connected in series. If the potential difference across the system is 12 volts, the potential difference across the 6 microfarad capacitor is, so let's move over to the board to provide answer to this question. So as you can see from the diagram, the capacitors are connected in series, okay? And when capacitors are connected in series, the potential difference across each of the capacitors are different, okay? Though they have the same quantity of charge, but the potential difference are different, okay? So in order to answer this question, first of all, we have to calculate for the effective capacitance, okay, of these capacitors. So remember that when capacitors are connected in series, then we solve them in form of the effective capacitance is equals to 1 all over the effective capacitance, then that will be equals to 1 over each of the capacitance, okay? So this one will be 1, this one will be 2, then plus 1 over, this one will be 3, okay, since we have 3 capacitance. So we just substitute the value because we want to get the effective capacitance of the circuit. So 1 over CFF will now be equals to 1 over 2 plus 1 over 3 plus 1 over 6, okay? So the SCM of these numbers, 2, 3, 6 is 6. So 6 into 2 into 6 is 3, 3 times 1 is 3, then plus 3 into 6 is 2, 2 times 1 is 2, okay, then plus 6 into 6 is 1, then 1 times 1 is 1. So if we add the numerator together, we'll be having 6, then all over the denominator, okay. So since we are looking for the effective capacitance, not 1 over the effective capacitor, we just invert this and also invert this. So whichever way, okay, if we invert this, we'll be having C, E, okay, C, that is the effective capacitance, to be equals to, then if we invert this also, we'll be having 6 over 6, which is equals to 1 microfarad, okay. So the effective capacitance is equals to 1 microfarad. Okay, now we have to calculate for the quantity of charge, okay, because the quantity of charge is the same for the 3 capacitors, okay. So using C is equals to Q all over V, we can actually calculate for the quantity of charge, okay. So we just cross multiply since we are looking for Q. So Q is equals to CV. But remember that our C, okay, which is the effective capacitance, is equals to 1 microfarad. So here we'll be having 1 microfarad, okay, times the voltage, okay, given to us in the circuit, which is 12 volts. So if we multiply, the quantity of charge Q will now be equals to 12 microfarad. Okay, it will now be equals to 12 microfarad. So the quantity of charge equals to 12 microfarad. Now, since we know the quantity of charge, then we can now calculate for the voltage across the 6 microfarad capacitors. Okay, so in this case, you still using this formula is just for us to switch the position of V, okay, for C. So if C is equals to Q all over V, then we can switch so that V is equals to Q, okay, all over C. So this will be equals to, now remember our Q is equals to 12 times 10 raised to the power minus 6 for microfarad, then all over this, which is the capacitance of the capacitor, which is 6 microfarad. So here we'll be having 6 times 10 raised to the power minus 6. So 10 raised to the power minus 6, we cancel out 10 raised to the power minus 6. Then 6 here is 1, 6 here is 2, okay? So we can say that the voltage across the 6 microfarad capacitor is equals to 2.0 volts. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option C, 2 volts. Question 43. If the distance between 2 point charges is increased by a factor of 4, the magnitude of the electrostatic force between them will be. So let's move over to this board to provide answer to this question. We know that the force between 2 point charges F, okay, is given as K, Q1, Q2 all over R squared. Okay, so let's call this F1. Okay, so for F2, we are told that this is increased by the distance, okay, between the two charges is increased by a factor of 4. Okay, so here we'll be having K, Q1, Q2 all over 4, okay, in brackets, R squared. Okay, because we are told it's increased by a factor of 4. Okay, so if this increased by a factor of 4, then F2 will now be equals to K, Q1, Q2, okay, all over 16 R squared. Okay, since F2 is equals to this, so but remember that the whole thing here like this, okay, is equals to F1. Okay, so in place of K, Q1, Q2, R raised to power 2, we can replace it with F1, so that F2 is equals to F1 all over 16. Okay, so this shows that the value of F2 is 1/6 of F1. Okay, so let's return back to the screen to pick the correct answer to this question. Okay, so which is option B, which is 1/16 of its former value. Okay, 1/16 of its former value. So that makes option B the correct answer to this question. Question 44. The velocity of sound in air will be doubled if its absolute temperature is. So let's move over to the board to provide answer to this question. So we know that the velocity of sound in air V is directly proportional to the square root of its absolute temperature. Okay, so V will now be equals to K root T, right? So let's call this V1 and let's also call this one V2. Okay, let's call this one T1 also. Okay, now remember that in this question we're told that if the sound of air is double, what will happen to the absolute temperature? Okay, so in this case we are going to double this to be so that V2 is now equals to 2 V1. Okay, so now take note here, since here we have V1, okay, all over root T1, and this will be equals to V2 all over root T2. Now, since if we make T the subject of formula, okay, by dividing both sides by root T1, so that K is equals to V1 all over root T1, and this is a constant, okay? So we can actually have another one in front of it since it is a constant. Okay, so let's just substitute our values to get the value of T2, because basically that is what we are looking for. But remember that our V2, okay, is equals to 2V1. So we'll be having V1 all over root T1 to be equals to 2V1 all over root T2. Okay, so here we simply cross multiply since we are looking for V2, right? So if we make root V2 the subject of formula, we'll be having root T2, okay, to be equals to root T1 times 2V1 all over V1. Okay, so V1 we cancel out V1. Now we are looking for T2, not root T2. So we simply take the square of both sides to cancel out or to kill off the square root. So if we square this one, we'll be having T2. Okay, that is if we take the square of root T2, we'll be having T2, and this will be equal to, if we take the square of root T1, we're having T1. Then times, if we take the square of 2, we'll be having 4. Okay, so that T2 is equals to 4T1. So that actually means that if we double the velocity of sound, then the absolute temperature will be quadrupled. Okay, will be the quadrupled of the original. So let's move over to the screen to pick the correct answer to this question, and that is option A, quadrupled. Do you have any question to ask? If you do, you can click on the link in the description below, and that will take you to my school website. There you can ask all your questions, and our army of solution providers will provide answers to all your questions within a short period of time. Moving on to question 45. A force of 200 Newton acts between two objects at a certain distance apart. The value of the force when the distance is halved is, so let's move over to the board to provide answer to this question. So remember that F is equals to G M1 M2 all over R square, okay? Because for this question we're told that the force acts between two objects, okay? They act between two objects. So those two objects have masses, okay? M1 and M2. So basically they are talking about gravitational force actually. Okay, so this is for F1. So for F2 we are told that the original distance was halved. Okay, so if the original distance is halved, that means the second distance for F2 will now be equal to 1 over 2 of the original. So this will be G, then M1, M2 all over, so here we'll be having 1 over 2 arrow all squared. Okay, so if we simplify this, we'll be having G M1 M2 all over 1 over, okay, arrow square, or let's just put it arrow square all over 4. It's still the same. 1 over 2 times arrow means arrow all over 2. So the square of arrow all over 2 will be arrow square all over 4. Okay, so remember this 4 is going to move up. So this 4 is going to move up. So if this 4 move up, we'll be having 4, then bracket G M1 M2 all over arrow square. But remember that G M1 M2 all over arrow square was given to us to be equal to 200 Newton. Okay, so in place of G M1 M2 all over arrow square, I'll replace it with 200 Newton. Remember, this was given to us in the question. So if I replace the whole of here with 200 Newton, I'll be having 4 times 200, and this will be equals to 800 Newton. Okay, so the value of force F2 is equals to, which is the new force, is equals to 800 Newton. So let's return back to the screen to pick the correct answer to this question, and that is option D, 800 Newton. Do you have better step or solution to any of these questions? If yes, you can go to the comment section below to comment the question number and the solution or step you wish to share. Question 46. If two inductors of inductance 3 Henry and 6 Henry are arranged in series, the total inductors of inductors arranged in series is just the sum of the value of the inductors. So in this case, we have two inductors, okay, of values 3 Henry and 6 Henry. So the total inductance will be equals to 3 plus 6, and that will be equals to 9 Henrys. And that makes option A the correct answer to this question. Question 47. An elastic material has a length of 36 centimeters when a load of 40 Newton is hung on it, and a length of 45 centimeters when a load of 60 Newton is hung on it. The original length of the string is, so let's move over to the board to provide answer to this question. So to answer this question, we are simply going to be applying Hooke's law. Okay, so according to Hooke's law, F is equals to K E, okay, where E here is extension. Okay, but remember that extension E is equals to the new length minus the original length. So take note of that. Okay, so here we just make K the subject of formula, so that we'll be having K to be equals to F all over E. Okay, so if K is F all over E, that means we can have F1 all over E1 to be equals to F2 all over E2. Okay, now since we said E is equals to L1 minus L0, now remember that L0 means the original length of the material, okay, before maybe a force was applied to, to increase it to the new length L1. Okay, so from here we can rewrite this to be equals to F1 all over, so here will now be L1 minus L0 being equal to F2 all over L2 minus L0. So we can now substitute these values into this formula, okay, so that we can calculate for the original length. So remember, F1 is equals to 40, then all over, so L1 is 36 minus L0, and this will be equals to, so F2 is 60 Newton, then all over L2, okay, L2 is 45, so you'll be having 45, then minus L0. So we just cross multiply, okay? Since we're having two fractions that are equal to each other, we cross multiply to get whatever we are calculating for. So let me clean this one off. Let's write it here. So L1 minus L0, okay? Or let's call it new length minus the original length, okay? So let's rule it from here so that we'll have enough space. So if we cross multiply, we'll be having 40 all over 45 minus L0 to be equals to 60, then in bracket 36 minus L0, okay, in bracket. So 0 can take out 0, 2 here is 2, then 2 here is 3, okay. So here we'll now be having 2 bracket 45 minus L0 is in bracket is equals to 3 bracket 36 minus L0. Okay, so we just open up the bracket. So if we open up the bracket here, we'll be having 90 minus 2 L0 to be equals to, so 3 times 36, that would be 108, then minus 3 L0. Okay, so we just collect like terms. So we are going to move this 90 to this side, and we'll move this to this other side. Okay, we'll move 3 L0 to our left hand side. So here we'll be having minus 2 L0, then plus 3 L0. Now our 3 L0 here is negative. So once it crosses the equal to sign, it's going to change to plus. That's the reason we have plus here. And this will be equals to 108. Then if we move 90 to this side, since it's positive, okay, once it crosses the equal to sign, it will not change to negative. So here we'll be having minus 90. So minus 2 L0 plus 3 L naught. That will be equals to 1 L naught. So here we have L naught, and this will be equals to, so here 108 minus 90, I think that should be equals to 18. So here we have 18. So the value of the original length is equals to 18 centimeters. Okay, so let's return back to the screen to pick the correct answer to this question, and that is option C, 18 centimeters. Question 48. In the photoelectric effect, which of the following graphs correctly represent the graph of stopping potential V0 against frequency F of incident light? Okay, so these are the graphs. So the correct graph is actually D, okay, which is this, okay, and the reason for that is because the relationship between stopping potential and the frequency of incident light is a straight line, okay, produces a straight line graph. Okay, the graph of stopping potential against frequency of incident light is a straight line graph, okay, but the graph, okay, actually cuts the s-axis at a point where the frequency of incident light is equals to threshold frequency. Okay, so as the frequency of the incident light increases above the threshold frequency, which is this point, so also the stopping potential corresponding to the kinetic energy of the photoelectron increases. Okay, so that makes option D the appropriate graph of stopping potential against frequency of incident light. So that makes option D the correct answer. Question 49. The amount of energy released when 0.5 kilogram of uranium is burnt completely is, so we are asked to take C to be equals to 3 times 10 raised to power 8 meter per second, which is actually velocity. Okay, so let's move over to the board to provide answer to this question. So to calculate for the amount of energy released, we are to use about Einstein equation for mass and velocity relationship, okay, where it said E is equals to mc squared. So basically this is what we use to calculate for the amount of energy released. Okay, so here we just substitute E will now be equals to 0.5, then times in bracket 3 times 10 raised to power 8 raised to power 2. Okay, so 0.5, let's put it in standard form, will be 5 times 10 raised to power minus 1, then times, this will be 9, then times 10 raised to power 16. Okay, times 10 raised to power 16. So 5 times 9 is going to give us 45. Then here we apply the law of indices. So at the end of the day, we are going to be having times 10 raised to power 15. Okay, but remember that this is 45 and this is not in standard form. So in standard form, we are going to move this one place inside. So that we'll be having 4.5 times 10 raised to power 16. Okay, since we are talking about energy, I think that should be joule, right? So this is the amount of heat released when 0.5 kilogram of uranium is burnt. So let's return back to the screen to pick the correct answer to this question, and that is option D, 4.5 times 10 raised to power 16 joules. Question 50. A motorcyclist traveling at 30 meters per second starts to apply his brakes when he is 50 meters from the traffic light that had just turned red. If he reached the traffic light, his deceleration is, so remember here the initial velocity will be 30 meters per second square, while the final velocity will be when he reached the traffic light. So when he reached the traffic light, at that point, the velocity there is equals to 0 because he actually stopped. So that is the final velocity. Okay, so let's move over to the board to provide answer to this question. Since we are calculating for velocity and we know initial velocity, we know distance, and we don't know the deceleration, which is negative acceleration, we are going to be using the last equation of motion, or let's call it the third equation of motion as the case may be, which is v squared is equals to u squared then plus 2a x. Okay, so the final velocity is 0, okay, which is when he actually stopped. Now remember that in the question we are told that from 50 centimeters started, he applied brake, okay, but he finally came to a stop when he got to the traffic, when it got to the traffic light. So u will be equals to 0 square, and here we'll be having u square, okay, then plus 2 times, okay, we already know the value of u, which is 30, so here we'll just use 30 square, so here will be 30 square, then plus 2a, okay, times the distance, 50 meters. So we'll move the 30 square to this side, but remember that 30 square is equals to 90, and 0 square is still 0. So if we move 900, sorry, 30 square is equals to 900. So if we move it to this side, we're having 900, okay, minus 900 to be equals to 100a. Okay, since we are looking for a, we simply divide both sides by 100. So a will now be equals to minus 900 divided by 100. So zeros, we take out zeros, so that a is equals to minus 9 meter per second square. Okay, so the reason why we're having negative value for a is because we're actually calculating for deceleration, and deceleration is negative acceleration. Okay, so the value of the deceleration is equals to 9 meters per second square. So let's return back to the screen to pick the correct answer to this question, and that is option C, 9 meters per second square. I believe you enjoyed this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, put on the notification bell to get informed as soon as we release the next videos.